Hi, this is King of Review. Find n if negative 972 is the nth term of a geometric sequence 4, negative 12, 36, negative 108, and the sequence continues. So we have something here called a geometric sequence. A geometric sequence is a sequence or list of numbers or terms where the ratio of any term to the previous term is constant. So this first term is called A1, the second term is called A2, and this continues. A3 is the third term. So that's how you name the different terms. So how do we get from 4 to negative 12? Well, we can multiply by a negative 3. 4 times negative 3 gives us negative 12. And how do we get from negative 12 to 36? Again, we multiply by negative 3. So you can see a pattern here. To get from 36 to negative 108, we multiply by negative 3. So this negative 3 is the ratio called the common ratio, and it can be calculated as R equals A2 over A1. You could also calculate it as R equals A3 over A2. So as long as you're comparing a term and comparing it to the previous term, then you can calculate R. So let's look at this. A2 over A1. So A2 is this value here, which is negative 12, and it's over a 4. So if you work this out, you get negative 3. So negative 3 is the common ratio. And let's just check this one here, A3 divided by A2. A3 is here, which is 36, and we're dividing that by A2, which is negative 12, and this gives us negative 3. So negative 3 is the common ratio. In this problem, we're asked to find n if negative 972 is the nth term. So at some point down the line in this sequence, we're going to get to negative 972, and we want to know what term this is. So a to the question mark, or a to the n. I want to know which term has the number negative 972. So one method for doing this is to just write out all of these terms, A1, A2, A3, all the way until you get to negative 972. This could take a while depending on how far down the sequence it is, but there's another way to solve. We can use the rule for a geometric sequence. This rule has the following formula. It's AN equals A1 times R to the n minus 1 power. AN here, we're going to be solving for n. A1 here, this represents our first term, so that would be a 4. R is the common ratio, and again, we're solving for n. So let's plug in this information. We have A1, which is 4, times our common ratio of negative 3 to the n minus 1 power, and we know that this is negative 972. So we have our equation here, and now we're trying to solve for n. So let's do that. The first step is to divide by 4 on both sides. So we get negative 243 equals negative 3 to the n minus 1 power. Now I want you to think about the property where if two powers with the same bases are equal, then their exponents must be equal. So let's think about this. If we have b to the x and b to the y, if we know that these are equal, then their exponents must be equal. So this is true as long as b is greater than 0 and b is not 1. So we have this property here. So let's rewrite negative 243 so that it has -3 for a base. So -3 to the 5th power is -243. And then we have -3 to the n minus 1. So now we have this property here. We have the same base, and because the bases are the same, then the exponents are the same. So we have 5 equals n minus 1. Now solve for n. We'll add 1 to both sides, and now we have n equals 6. So now we know that -972, this equals a to the a6, which is the 6th term of this sequence. So letter A is correct. Thanks for watching.